Okay, in this video tutorial, what we're going to do is we're going to explore how to convert between fractions and decimals. And this should be fairly simple, but there are a couple tricks that you need to be aware of. Basically, when we're converting a fraction, so in this case we're going to convert 13 over 20 into a decimal, the basic technique here is we're just going to take the numerator and we are going to divide it by the denominator. This is a practice in long division here. So numerator divided by denominator, and that'll work every time. Now there's some other techniques as well that involve using some mental math and maybe some ratios and proportions. But if you're ever stuck, this will always work. It's a little bit of a pain, but it will get the job done. So in this case, I'm going to take 13 and I'm going to divide it by 20. Now, if you remember your long division, 20 does not go into 13 at all, so that's a 0. So to deal with that now, I need to put in a decimal point. That decimal point moves straight up into my quotient, and I'm going to add a 0 here. So the question now is, how many times does 20 go into 130? I know it goes 6 times. 6 times 20 is 120. Subtract, get 10. Add another 0, bring it down, and 20 goes into 100 5 times. And I think it goes exactly 5 times. 20 times 5 is 100, and then when I subtract, I get 0. So 13 over 20 as a decimal is 0.65, or 0 and 65 100ths. The second one, what we're going to do is we're going to convert negative 5/6 to a decimal, and we're just going to use the exact same technique here. So I'm going to take my numerator, 5, and I'm going to divide it by my denominator, 6. Now, it is negative, and I'm not going to leave that negative sign out, so I'm just going to kind of remember that it's there to deal with later on. Now the same thing again, and we know it's going to be less than 1 because the numerator is smaller than the denominator and there's no whole number. So this makes sense. 6 does not go into 5, so I need a 0. Here's my decimal. Add a 0, move the decimal up. 6 goes into 58 times. I'm just going to extend that. 8 times 48. 50 minus 48 is 2. Add a 0, bring it down, 0. 6 goes into 23 times. 6 times 3 is 18. 20 minus 18 is 2. Another 0. Bring it down. 0. 6 goes into 23 times. 3 times 6 is 18. Now, I'm going to actually stop here because I'm noticing that I have a pattern forming, and that is that 20, 18, 20, 18. I think this is going to go on forever. So these 3's are more than likely going to go on forever. So what I have here is a case where I have a repeating decimal. It still is a rational number because it's a fraction, but as a decimal, it's a repeating decimal. So to write this, negative 5/6 is equal to, don't forget the negative now, negative 0.83. And to show that the 3 is repeating, I'm going to put a bar just over top of the 3, and that shows that the 3 goes on and on and on forever. Now let's explore how to convert decimals into fractions, and this is really an exercise in place value. What I'm going to do is I'm going to take a look at the final digit, and I'm going to look at what place value that is in. So this 5 is in the thousandths, right? Don't forget the THS, the thousandths place. So really, if I say this number, it's 225 thousandths. So I'm going to use that to write this as 225. So there's the decimal portion here becomes my numerator. And since that last digit is in the thousandths place, this is over 1,000. So now all I need to do is I need to look to simplify. And so I know that 5 is a factor of 225 and of 1,000. So 5 goes into 225 for 245 times, and out 200. 5 is still a factor. 5 over 5 equals 45 divided by 5 is 9. 200 divided by 5 is 40. So in the end here, right, 9 and 40 cannot be simplified anymore, so I know that 0 and 225 thousandths is equal to 9 over 40. This last one here really is the trickiest because we have a repeating decimal. Remember, that bar there tells us that that 7 goes on and on forever. So we can't use the same trick of where's the final digit or what place value does the final digit have. So we can't use the same trick of what is the place value of the final digit because there is no final digit. So for this one, we're going to use a little bit of algebra. And what I'm going to say is 0.7, I'm just going to add a couple other 7s to show that it goes on forever, is equal to x. Now I'm going to do something a little bit weird here. And what I'm going to do is I am going to multiply each side of my equation by 10. So I'm going to multiply it by 10, and I'm going to multiply it by 10. And if I do that, what I really end up with above here is 10x is equal to 7.777 go on forever. Now, the significance of doing this is a strategy that you can use, and you'll learn more about this in algebra really, is that you can subtract one whole equation from another. So what I'm really going to do is I'm going to subtract the equation in purple from the equation in red. So let's take a look at that. I'll start with the x's because we've done a little bit more with that. If I subtract x from 10x, or 10x minus x, I'm left with 9x. If I subtract 0.777777 going on forever from 7.77777 going on forever, the 7s that go on forever are actually going to sort of eliminate one another, leaving me with just a whole number. So now I have that 7 is equal to 9x. So now this is just a simple one-step equation. Divide by 9, divide by 9. My 9's cancel out. And what I get is that 7/9 is equal to x. Now, don't forget that at the very beginning here we said that, and I'll just write this out again, we said that x was equal to 0.7 repeating. So if x is equal to 0.7 repeating and x is equal to 7/9, what we conclude from that is that 0.7 repeating is equal to 7/9. So this is a little bit trickier in terms of converting a repeating decimal into a fraction.